our next presenter from IUTA.
Can you see the slides?
Yep, ready whenever you
I
are.
have a lot of slides. I have a lot of slides, but I was I was actually training kids in the afternoon, so my voice is not really the best, but I will do my best. And I will not really go in detail into the slides, but I will just showcase what we have done. And basically, this talk is just to highlight how important is actually these generic frameworks for data standardization. And one of the struggles that we have in environmental analysis, for example, this example is actually when you look at wastewater treatment and you look at the monitoring of these kind of systems, you are not looking at one type of data. You have like a very diverse pool of data that you need to handle. And often practitioners, they need to kind of really handle a lot of software to handle the data, to process the data, and then to bring the data into kind of results that they can kind of better assess. And the problem here is also that you have a very then challenging, how can I say, like draw of conclusions, because it's very difficult then to bring different types of data together to have like combined correlations and to have a better understanding of the process. So this was a challenge that I actually experienced myself when I started actually the position I'm now. And this then led to the idea that, okay, we need to be more interoperable so that we can better easily interact with the data and have the data interacting with each other. But of course, to do this, we also need competences. We need the normalization of software so that we can be more fair. So that was the motivation behind the project StreamFind, which we did in cooperation with Forschungszentrum from Karlsruhe. So they are kind of like T experts. We are very much connected to practice. So I'm not an IT guy. I mean, I have some some affinity or competences, but definitely my background is biological engineering, so not really much connected to software development. But it was an interesting cooperation we had with them, and of course we also had a network of partners, including, for example, Applicate, where we also did some work together. But StreamFind was rather focusing on data processing. So the concept I show you here, it's recorded, you can always inspect it, but I will focus on the actual processing that we implemented so that I can also highlight what is the challenge now that we are facing. One is what we thought of using as a workflow is like allowing the user to just assemble a list of instructions that will transform the data. So that was one of the biggest challenge that we had, is we could not really achieve the transformation that we needed. So basically the processing that we needed with the vendor software, with the tools that we had available. So we needed flexibility for most of the research that we are doing in-house, but also some cooperation partners. So the idea here was to create a framework that allow us to develop or deploy an algorithm and then have that instruction being added. And we found this JSON representation, which as JSON is also very alike with ASM. But basically, this is how we describe a processing step that will transform a given type of data. And on the right side, you can see an example for mass spectrometry, where the idea here is that we annotate found chromatographic peaks, and we are going to annotate the isotopes and adducts based on an algorithm that I kind of developed myself, because I could not really found at the moment, I could not really have that done properly. So that was kind of something that I added to the framework as an algorithm, and then I can use it with these instructions. A workflow for something that we do very often, which is known target screening. So basically detect unknown chemicals in environmental samples. This is a very kind of conventional workflow. We go from raw data to results. And in this case, we have 21 different steps. So basically the idea here is that we kind of have this JSON file with all the instructions, and then we can have these as a kind of like template to process the data, something that we also can save and then reproduce in another experiment, and having sure that everything is then the same way it was done with the other samples, because these instructions will also have like this list of parameters which defines how the algorithm was implemented. Within of course, during the processing, we also produce results. And at the moment, of course, what we are doing is that we accommodate these results in a flexible way, having these object representations that the user can then export, but also just use for plotting the data. But the problem is that they have a very different structure, but originally they are always from the same kind of data type, right? So, but the idea here is that we kind of have this diversity of results being added, and then user can do operations on them as they need. Some example here on this workflow that I just showed. So the first step is just like gets the number of chromatographic peaks that was found. And here what we are doing is that we are comparing a wastewater treatment step, so an ozonation of wastewater. And we compare, the idea here is to compare the influent and the effluent of different techniques, and then see like what happens with the chemicals there. So from the number of chemicals, we cannot really say much. So we continue with workflow. Something that we also developed natively was gap filling. So the feature finding was not working properly. So we kind of develop kind of like an add-on or an algorithm that could kind of remove or reduce the false negatives. For example, here you see that metoprolol, which is kind of a chemical that we found in the influent sample, was not found with the native algorithm for finding features, but then recursively could be integrated and added to the list. Something that we often have done is that we did find a lot of algorithms, a lot of concepts for processing data, very interesting as literature. So literally this was a paper that was written of a concept to correct matrix suppression of the mass spectrometry. And what we have done is that we took this, we contacted the developer, and we took this, we converted into a running script that we could then implement into the workflow and have it as a step. So basically what it does, it just looks into the tick profile and then kind of draws the suppression factor in reference to a blank, and then scaling it with internal standards so that we have a better comparison between samples with different matrices concentration, let's say. For example, influent would have like a higher suppression than effluent, and we can kind of correct for that differences for a better comparison between influent and effluent. Here we do some suspect screening, so we are looking for some suspects that we know that are there or that might be there, and we can see, for example, that from the influent to the effluent we see a drop as expected in the chemicals, but we also see the effect of this correction of the matrix suppression. So basically the removal will be underestimated without it. Not only algorithms, but also plotting concepts that we took from literature. So here, for example, we see the full change analysis done on a percentage wise. And often when you have like a treatment operator, what he wants to know is how many features I am removing at 80%, because that's what the regulation tells. And here we see that about 75% are removed. Of course, there's a lot being formed, and this is what we can then assess afterwards. And here, for example, I'll just give an example of estriol, which is an estrogen, which we could see that it was removed, but the transformation, so the oxidation transformation was formed. So this is often the case, and so this workflow allows the operators or the technicians to actually be aware of how many transformations are going on there. The diversity of workflows that you can implement, we also worked on that. For example, here you see a workflow for just quantification of LC-DAD data. So it's just a simple kind of integration of the chromatograms and then running a linear regression. So something that we also did was we provide some services for identification of intact monoclonal antibodies. We also did that, implemented as a workflow in the StreamFind, and this was on mass spectrometry, but the idea is that we do also like kind of cross-data analysis. We also work on Raman spectroscopy, and here you have an interesting use case where we coupled Raman spectroscopy with size exclusion chromatography. So we have like a two-dimensional data set, and then we also have a workflow where we deconvolute these 2 dimensions, and then we can have the spectra of the Raman over the separation of that exclusion, where we can see, for example, the black peaks here are representative of the monoclonal antibodies, and then we have the formulation ingredients of this product that allows us to differentiate different products of the same monoclonal antibody. So that was the idea here. Right. The concept for expanding these is just looking into expanding the amount of processing algorithms that we have to enable transformation of data. But of course, we also do this in cooperation with quite some partners in our network. So the problem again is these objects, they are not fair. And in the upcoming project, CogniFlow, where we are cooperating with Duisburg-Essen University here in Germany, in cooperation also with some practitioners. So those are water boards, so entities responsible for monitoring of surface water, wastewater. The idea here is that we are looking rather into how the data can come into processing, how the data can come out and be used afterwards. So this is a very complex map, but the idea here is that we use the same framework of StreamFind, so this list of processing steps that create kind of a pipeline, and then we just kind of like create a database where we can store the results. But then again, here the ASM would be a very interesting asset for us to actually be able to deploy results in an interoperable way, because we are flexible in the objects creation, even in the database, but the interoperability of the results with other frameworks or other softwares is very limited unless you have like a common front. And I think ASM, both for data import and data export, can really play an interesting role here. Something that we have also highlighted here is this interactive integration of reporting. So leveraging these markdown like Quarto frameworks or similar to Jupyter notebooks, which allows them to on the fly produce HTML reports which are interactive. So this is in a nutshell what I wanted to share. So ultimately what we would like to do is to have the guy a little bit more relaxed in terms of handling the diversity of data that you have in this environmental analysis. And if you would like to know more about what we are doing, you have the book that was edited by my colleague Torsten Tutteberg, where we go over the different aspects of Laboratory of the Future, and we describe StreamFind there and other topics as well. So that was it. Thank you very much for your attention. And if you are interested in more projects that we have that we are doing, the GitHub account or their project will have that stored. We're also working on an e-learning platform to promote the share of competencies, where we are creating very short tutorials on algorithm concepts. And this is also connected to the lectures of my colleague Gerrit Renner from the University of Duisburg-Essen. That's something interesting because these tutorials, they are interactive. So you can interact with the data processing in a kind of like in a interactive way, I would say. Thank you.
Thank you, Ricardo.